All right, this recording is introduction to the unit PreCalculus A, Unit 1, Lesson 3 on relations and functions. So I'm going to highlight some of the main points of the lesson this week, or today, and not going to go into extreme detail, but give you a brief overview of what to expect. All right, the key terms are relations and functions. A relation is often called a mapping. It is a pairing of numbers, right? So we can define a relation, for example, as the number 1 is paired with the number 3. And the number 2 is paired with the number 5. The number 3 is paired with the number -2. And let's include this one here. The number 1 is paired with the number 4. Notice that 1 is paired with 3 and 1 is paired with 4 as well. You can repeat numbers there. It's just a mapping, and in fact, it's not in this unit, but we can declare all of the input, all of the first numbers, to be our x values, the input, and the y values are output. X input, y output. All the x values are called the domain, the main do, and the output values are called the range. So in this particular case, the domain values I'm going to put over on the left, and the range values I'm going to put on the right. And this is called a relation mapping. Okay, the domain values are 1, 2, 3, and 1 again, which I'm not going to list the 1 twice. And then the output, the range, is 3, 5, -2. I'm going to put them in order. -2, 3, 4, and 5. Okay, and we map the elements of the domain to the elements of the range. So 1 goes with 3. Okay, 1 also goes with 4. Okay, 2 goes with 5. And 3 goes with 2. All right. So the domain input, the range output. Okay, and the arrows flow from domain to range. All right. So that's a relation or a mapping. A function is a special kind of relationship or relation. Okay, a function can be thought of as, I think I presented this before, a machine, right? That is, we have something we put in, input, usually x, all the x are the domain, and we turn the crank through some function rule, whatever it might be, and out comes the output, or the y value, or the range. Now, what makes a function different from x, or from a relation, is that the function machine needs to be consistent. Okay? If I input the same input twice, should give the same output. Same input, same output. Okay? If I came along and put in the number 1 and got out 3, but then I put in the number 1 again, but this time I got out the number 4, you would conclude the machine is broken. Okay, and it is not therefore a function. So this is not a function because it breaks the rule that any unique input must produce a unique output. So putting in 1 twice, I should have gotten 3 both times, or 4 both times. I can't get the same output twice. Now I want to examine these 2 points on a graph. Okay, I'm just going to do a quick I like to call it poor man's graph. Little x and y axis plus sign here. Let's graph 1, 3, 1, 3, and 1, 4. 1, 3, and 1, 4. And I want to ask you a question. Do you notice what relationship those two numbers have to each other, those 2 points have to each other? Now, hopefully you recognize that they're aligned up vertically to each other, one right over the other. And so this brings up something called the vertical line test. Vertical line test. Okay? And the vertical line test says this. Vertical line test. It says if a vertical line touches a graph more than once, the graph does not represent a function. Okay? Does not represent a function. Okay? So those are some of the things that we need to be familiar with when we're talking about functions. Now, functions, and we're going to deal with mostly functions in this class. There are sometimes we'll deal with some relations that are not functions, such as circles and ellipses and some of the conic sections. Okay? But most of the time we're going to be dealing with functions. Functions come in 2 flavors. They are continuous. There's more than that, but we're going to deal with continuous, and we're going to deal with discrete. Continuous is, as the name suggests, every value is represented. So the domain might be all real numbers. Okay? Whereas if a function is discrete, the domain might be integers in the set from -3 to 3. Okay? And we could have the same function rule for both. Let's say y equals 2x, or f of x equals 2x. Okay, f of x equals 2x. So let's see how this plays out. If I use the discrete case, I input a -3, a -2, a -1, a 0, a 1, a 2, a 3. As our x values, and our f of x values. 2 times -3 is -6, 2 times -2 is -4, 2 times -1 is -2, 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. I can now graph this relation over here. And here we go. Okay, x and y. And I can plot these points, -3, 6, 2, 4, 6, and so on. And you end up with this linear function, but it is discrete points. Okay, this is discrete. Whereas if I were to represent the continuous case where the domain is all real numbers, then in that case, the result, and I'm just going to use the same graph here, the result would be a line. We fill in the dots. There is no space, no gap. There are no gaps in the representation. So that's discrete, while the green represents continuous. Okay? And hopefully that makes sense. I think that's about everything on here. yeah, I'm going to leave it at that. Well, let me know if you have any questions. Feel free to book a live lesson.